Water is essential for all life on Earth. From the smallest microorganism to the largest whale, every living thing needs water to survive. Plants need water to grow and produce their food. Animals, including humans, need water for drinking, digestion, and to regulate body temperature. Without water, life as we know it would not exist. Imagine a world without the refreshing taste of water, a world where plants wither and animals struggle to survive. Water is the lifeblood of our planet, coursing through ecosystems and sustaining every living being. It is the vital force that allows flowers to bloom, trees to reach for the sky, and creatures to thrive in diverse habitats. Water is not just about survival. It is about the beauty and wonder of the natural world. The crashing waves of the ocean, the gentle flow of a river, the delicate droplets of dew on a spider's web. All these remind us of the magic and importance of water. It is a precious resource that we must cherish and protect. While our planet is covered mostly in water, only a small percentage is freshwater suitable for our needs. This precious resource is distributed unevenly across the globe, found in various forms and locations. Lakes, rivers, and groundwater aquifers are all vital sources of fresh water that sustain ecosystems and human populations. Lakes, like shimmering jewels scattered across continents, hold significant amounts of fresh water. These bodies of water, ranging from small ponds to vast inland seas, serve as habitats for a myriad of species and provide us with drinking water, irrigation, and recreational opportunities. Rivers, like arteries carrying lifeblood, wind their way across landscapes, connecting mountains to oceans and replenishing ecosystems along their course. They are dynamic systems, constantly moving and shaping the land, providing habitats for diverse aquatic life and supporting riparian communities. Hidden beneath the surface lies another critical freshwater source, groundwater. Stored in underground aquifers, these vast reserves of water are essential for human consumption, agriculture, and industry. Groundwater sustains ecosystems in arid and semi-arid regions, providing a lifeline for plants and animals in water-scarce environments. Glaciers, massive rivers of ice that form over centuries, hold the largest reserves of freshwater on Earth. These frozen giants, found in polar regions and high mountain ranges, play a crucial role in regulating global climate and sea levels. As glaciers melt, they feed rivers and replenish downstream water sources, supporting ecosystems and human populations. Rain is essential for replenishing these freshwater sources. When rain falls, it percolates through the soil and replenishes groundwater aquifers. Rainwater also flows over the land as runoff, replenishing rivers and lakes. This continuous cycle of rainfall and replenishment ensures the availability of fresh water for all life on Earth. The process of replenishing groundwater aquifers, known as recharge, is essential for sustaining this hidden water source. As rainwater infiltrates the soil, it slowly moves downward, replenishing the aquifers and ensuring a long-term supply of fresh water. This underground reservoir plays a crucial role in sustaining ecosystems, especially during periods of drought when surface water sources become scarce. Runoff, the flow of water over the land surface, is another vital pathway for rainwater to replenish freshwater sources. As rain falls, it flows over the land, carrying with it dissolved minerals and nutrients, eventually reaching rivers, lakes, and wetlands. This influx of fresh water nourishes ecosystems, replenishes water levels, and supports a wide array of plant and animal life. The replenishment of freshwater sources by rain is a continuous process, ensuring the availability of this vital resource for all life on Earth. It is a testament to the interconnectedness of natural systems and the importance of preserving the delicate balance of the water cycle. The water cycle is a continuous process that describes the movement of water on, above, and below the surface of the Earth. This natural process ensures that water is constantly being recycled and made available to all living things. The The water cycle has no starting point, but we can begin to understand it by exploring the process of evaporation. Evaporation is the process by which water changes from a liquid to a gas or vapor. This process is driven by heat energy from the sun. As the sun warms the surface of the earth, water in lakes, rivers, oceans, and even in the soil evaporates and rises into the atmosphere as water vapor. As water vapor rises into the atmosphere, it cools and condenses into tiny water droplets. These droplets clump together around microscopic particles in the air, forming clouds. Clouds are visible masses of water droplets or ice crystals suspended in the atmosphere. Precipitation occurs when the water droplets in clouds become too heavy to stay suspended in the air. They fall back to Earth in various forms, including rain, snow, sleet, or hail. The type of precipitation that occurs depends on the temperature of the atmosphere. Evaporation is a fundamental process in the water cycle, driven by the sun's energy. As sunlight bathes the Earth's surface, it warms the water molecules in lakes, rivers, oceans, and even the soil. These energized molecules begin to vibrate faster, and some gain enough energy to break free from the liquid state and escape into the atmosphere as water vapor. The rate of evaporation is influenced by several factors, including temperature, humidity, wind speed, and the amount of solar radiation. Higher temperatures provide more energy for water molecules to evaporate, while lower humidity creates a greater difference in water vapor concentration between the surface and the atmosphere, facilitating evaporation. Wind plays a significant role in enhancing evaporation. As wind blows across a water surface, it carries away the water vapor that has already evaporated, creating space for more water molecules to escape into the atmosphere. This continuous removal of water vapor maintains a concentration gradient that promotes further evaporation. The process of evaporation is not limited to open water bodies. Plants also contribute to the water cycle through transpiration. Through tiny pores called stomata on their leaves, plants release water vapor into the atmosphere as a byproduct of photosynthesis. This process, combined with evaporation from the soil, contributes significantly to the amount of water vapor in the atmosphere. Precipitation, the process by which water returns to Earth's surface from the atmosphere, is a vital component of the water cycle. As water vapor rises and cools in the atmosphere, it condenses into tiny water droplets or ice crystals, forming clouds. These clouds, carried by wind currents, travel across the globe, eventually releasing their accumulated moisture in the form of precipitation. The type of precipitation that occurs depends on the temperature of the atmosphere through which the water droplets fall. When temperatures are above freezing, precipitation falls as rain. However, if temperatures are below freezing, precipitation can take various forms, including snow, sleet, or hail. Snow forms when water vapor in the atmosphere freezes directly into ice crystals without passing through the liquid phase. These ice crystals, often intricate and hexagonal in shape, accumulate and fall to the ground as snowflakes. Sleet, on the other hand, occurs when raindrops fall through a layer of freezing air near the ground, freezing into small translucent ice pellets. Hail, the largest and most destructive form of precipitation, forms within thunderstorm clouds. Strong updrafts within these clouds carry raindrops high into the atmosphere where they freeze. As these frozen pellets are tossed up and down within the cloud, they collide with supercooled water droplets that freeze on contact, causing the hailstones to grow in size. Once the hailstones become too heavy to be supported by the updrafts, they fall to the ground. The movement of air, driven by pressure differences and influenced by the Earth's rotation, plays a crucial role in shaping weather patterns and driving the water cycle. Air pressure, the weight of the atmosphere pressing down on the Earth's surface, varies depending on temperature and altitude. Warm air, being less dense, rises, creating an area of low pressure, while cold air, being denser, sinks, creating an area of high pressure. This pressure difference between areas of high and low pressure drives the movement of air, creating wind. Wind is the horizontal movement of air from an area of high pressure to an area of low pressure. The greater the pressure difference, the stronger the wind will be. Wind plays a vital role in the water cycle by transporting moisture-laden air from one location to another. As wind blows across oceans, lakes, and other water bodies, it picks up water vapor through evaporation. This moisture-laden air is then carried by wind currents, sometimes over vast distances, until it reaches areas of lower pressure, where it rises and cools. As the air cools, the water vapor condenses, forming clouds and eventually leading to precipitation. The Earth's rotation also influences wind patterns through the Coriolis effect. This effect causes moving air masses to be deflected to the right in the northern hemisphere and to the left in the southern hemisphere. The Coriolis effect contributes to the formation of large-scale wind patterns, such as the trade winds and the jet stream, which play significant roles in global weather patterns and the distribution of precipitation. The distribution of rainfall throughout the year is not uniform but varies significantly depending on geographical location and seasonal changes. Several factors contribute to these variations, including the Earth's tilt, the movement of air masses, and the presence of geographical features such as mountains and oceans. The Earth's tilt of 23.5 degrees on its axis plays a crucial role in determining the seasons and the associated variations in precipitation. As the Earth orbits the Sun, different regions receive varying amounts of solar radiation throughout the year. During summer in a particular hemisphere, the hemisphere is tilted towards the Sun, receiving more direct sunlight and experiencing warmer temperatures. This leads to increased evaporation, higher humidity, and a greater likelihood of precipitation. The movement of air masses, driven by pressure differences and influenced by the Coriolis effect, also contributes to variations in precipitation. Air masses are large volumes of air with relatively uniform temperature and humidity. As these air masses move across the globe, they interact with other air masses of different temperatures and moisture content, leading to the formation of weather fronts and precipitation events. Geographical features such as mountains and oceans can also significantly influence precipitation patterns. Mountains act as barriers to the flow of air masses. When moist air encounters a mountain range, it is forced to rise, cool, and condense, leading to precipitation on the windward side of the mountains. This phenomenon is known as orographic lift. On the leeward side of the mountains, the air descends, warms, and becomes drier, resulting in a rain shadow effect with significantly less precipitation. The delicate balance of the water cycle, a lifeline for all life on Earth, is being disrupted by the far-reaching impacts of climate change. As global temperatures rise due to the increasing concentration of greenhouse gases in the atmosphere, the water cycle is intensifying, leading to more extreme weather events, altered precipitation patterns, and shifts in freshwater availability. The warming climate is causing more water to evaporate from oceans, lakes, and land surfaces, leading to higher levels of atmospheric moisture. This, in turn, is fueling more intense rainfall events in some regions, increasing the risk of floods, landslides, and soil erosion. Conversely, other regions are experiencing more frequent and severe droughts as warmer temperatures increase evaporation rates, depleting water sources and intensifying arid conditions. These shifts in precipitation patterns are disrupting agricultural practices, straining water resources, and increasing the vulnerability of ecosystems and human populations to water scarcity. The melting of glaciers and ice caps, another consequence of climate change, is further exacerbating these challenges. As these frozen reservoirs melt at an alarming rate, they contribute to rising sea levels, threatening coastal communities and ecosystems. The loss of glaciers also disrupts downstream water supplies, impacting communities and ecosystems that rely on glacial meltwater for irrigation, drinking water, and hydropower generation. The disruption of the water cycle by climate change is a stark reminder of the interconnectedness of Earth's systems and the urgent need for collective action to mitigate greenhouse gas emissions and adapt to the changing realities of our planet. The future of water security, and indeed the well-being of all life on Earth, hinges on our ability to address this global challenge with unwavering commitment and a sense of shared responsibility.